Hi everybody, in this video I'm going to go through our examples for our lesson 6.4, working with triangle bisectors and the circumcenter. So example 1, oh, wrong page. We are going to find the coordinates of the circumcenter, and the images that I'm about to use are in the OMHS. So please head there and either recreate the images or print it out if you can. The first image is this one, and it has the coordinate plane with our triangle. I think it would be very nice, right? If we need to find the coordinates of the circumcenter, let's find the coordinates of A, B, and C. So A is the point -1, 3. B is the point 5, 3. Those points have the same height. And C, that has the same X value as B, but different height, 5, -5. Now, a key note here is that the circumcenter, remember that's the intersection of all of your perpendicular bisectors, but I mean, still two of them go through that point. So what I can do here is I can find the intersection point for two of the perpendicular bisectors. Now I know you're like, I can't see the perpendicular bisectors. Well, we can find them in this triangle. Because notice that two of my lines, AB and BC, those are just, horizontal and vertical line. So let's think about where the midpoint of AB would be. Midpoint of AB. So this really, I'm going to find the average, right, of my X and my Y coordinates. They have the same Y coordinate. They both share, if I'm looking at A and B, the midpoint should have the same coordinate. I mean, that visually looks like where it is, but I don't think that's quite right. It should have a height of 3. So this midpoint is going to have a height or a Y coordinate of 3. The X coordinate then is just an average of our two X coordinates, -1 and 5. So -1 plus 5 divided by 2. And -1 plus 5 is 4 over 2. So the midpoint here is 2, 3. So what's the perpendicular bisector? Well, it is a line perpendicular, which has an opposite slope, right? That opposite reciprocal slope. Well, this is a horizontal line. So our perpendicular bisector would have to be the line X is equal to 2, right? It'd be this vertical line going through this midpoint, which has an X coordinate of 2. So our perpendicular bisector to AB would be the line X equals 2. Now let's do the same thing, but for BC. So first I'll start by finding the midpoint of BC. And this time, these 2 points, B and C, they share the same X coordinate. So the midpoint is going to have the same X coordinate, but the difference now is between the Y's. So let's find the average. It's 3 and -5, which we're going to divide by 2. So 3 plus -5, that's -2 over 2, which means this midpoint here is 5, -1. So let's plot that point right here. Oh. So what would this perpendicular bisector be? Well, now the line we are trying to construct a bisector through, this line is vertical. So our perpendicular bisector should be horizontal, meaning it's going to have a y equals equation, and it goes through the y value of -1. So this equation would be y equals -1. Where do these two intersect? I graphed it pretty nicely. I hope you recognize x should be 2 and y should be -1. So it would be at the point 2, -1. So this circumcenter is at 2, -1. And if I construct the perpendicular bisector, it would be, for that last side, it would be going through the point 2, -1. and it would have an opposite reciprocal slope to the slope of AC. Please let me know what questions you have on this one. I want to do one more example that's not in the coordinate plane. So, oh, this image got hidden. Question 2, final example that we're going to do for this lesson. Segment DE, DF, and DG are the perpendicular bisectors in triangle ABC. DG, the length of DG is 2, and the length of CA is 9.6. Our goal here is to find what is the measure of DB. And here is the image. Please, you could recreate this if you can't print it out. You could draw it pretty quickly in your notes. And I think it's very helpful to label what we know. So DG, this side here is 2. And CA, that is 9.6, right? So this is 9.6. I think it's important to note, since DG is the bisector, right? G is the midpoint of CA, of segment CA, which means then that CG and CA, those are the, or not CA, sorry, GA, those two are the same measure, and really 2 times CG, that's equal to the entire CA, right? The entire length of CA, that entire long side, is 2 times one of the halves. So if I know DG, I could find one of the halves, right? Which forms a right triangle with either DC, right? I have triangle DGC, or I have right triangle DGA. So if I think about just DGC, well, half of 9.6 is 4.8. So that means CG is 4.8 units. So this side right here is 4.8, and DG is 2. So now I can find this hypotenuse, right? This diagonal DC. Now, why does that help me? If I'm trying to find DB, which we never actually highlighted that, DB is the distance from this circumcenter D to the vertex of B. So if I know the distance from the circumcenter to any vertex, it's going to be the same as this DB. So let's find the measure of DC, because then that's going to be the same. So I'm going to make that note even. DC, that's going to be the same distance as DB, which is even the same as DA, because that's the distance from the circumcenter to a vertex in our triangle. So how do I do that? Well, this is a right triangle. And in a right triangle, we can always use the Pythagorean theorem, right? If we have A, B, and C, A squared plus B squared is equal to C squared. So that's the general idea we're going to use here, except the sides that we have, oh no, too far. The sides that we have, I can say that DG, right? This leg DG squared, that's like our A squared, plus CG squared, that's like our B squared, that's going to be equal to DC squared. And if it helps you, draw the little triangle out. Draw out the little right triangle. That turned out so bad. There you go. So here is D and G and C. So you can draw it out that way if that helps you. DG is 2. So I have 2 squared plus CG, which is 4.8 squared, and that is going to be equal to whatever DC is squared. Now 2 squared, that's 4, plus 4.8 squared is actually 23, oops, 0.04. So DC squared, whatever that is equal to essentially 27.4. So I can take the square root, right? I'll take the square root of each side. Square root, which is going to tell me then that DC is equal to, believe it or not, if you take the square root of 27.04, it is 5.2. So DC is 5.2, which means then, right, if DC is 5.2, so is BD, right? That's 5.2, and so is DA. These are all 5.2 because they are all the same distance from the circumcenter to that vertex. So because DC is 5.2, so is DB. Please let me know what questions you have on circumcenter. It's a really cool concept, and I look forward to seeing you in class.